We're recording?
Yes.
We have started.
Okay.
Great. So first of all, I would like to welcome everyone, welcome to everyone who is attending this call. I see we have a lot of people from our company, and I also see we have quite a few people who are external. So I believe that's great. I believe that's really great because open source software is about welcoming everyone and welcoming everyone to contribute to innovation and to source code and to develop new things. Okay, thank you. So during this Mind Technical talk, we are actually summarizing what we have learned, we as Mind Ascension have learned at the recent Fosdem conference in Brussels. Fosdem is an open source software conference. And
Sorry.
no problem.
Trying to make it full screen. Yeah.
Fosdem is an open source software conference, and I would like first to explain a bit what, in my opinion, open source software really means. So in daily life, in practice, we all know that open source software is a collection of open source software components where everyone, in principle, everyone can contribute. And then it's interesting to know that scientific principles are applied when open source software is being developed. And scientific principles, I mean things like merge request is done and then other people review the quality of your code, which is something like what we could call peer review. We organize conferences to disseminate knowledge, to disseminate what we have developed, and such that other people can learn about it. And in this way, open source software has had a great influence on innovation in our society over the last many, many years. Important to note here is also that this is not just an open source software activity. No, it's much more. There is a legal underpinning for this. I believe Arnout is going to talk a little bit about this. I cannot emphasize this enough, how important this is for open source software. And in this way, open source software is not just some collection of open source software components, but it's also a movement. And a very beautiful conference has been organized in Brussels, which nicely reflects the values of this movement, and that is Fosdem. Several colleagues of Mind have attended that conference, and we are jointly highlighting a few of these of the presentations that have been done at Fosdem. Frederik is going to start with MicroPython. I will cover a few presentations of Tool-the-Docs, the Tool-the-Docs definitely. Then Olivier is diving into the core of embedded software with Hugo and Linux. Raphaël will try to make Wi-Fi great again. I'm then going to continue with discussing a few things about low-level optimizations, specifically about AI and compilers technology. Olivier continues with security, which then also lines up with legal elements. And then Arnout will give a quick overview of other interesting talks, but mostly lightning talks. And one of those, I believe, is also about legal aspects of open source software development. So Frederik, you are the person to go first. So I will change seats again.
Thank you very much for that great introduction, Hugo. So yeah, so the talk that I want to highlight is a talk about MicroPython. Basically, MicroPython is a from-scratch implementation of Python, specifically designed for either microcontrollers or for very memory constrained systems in general. So it was created from scratch in 2014. So it's still relatively new. They try to make it as compatible with CPython as possible. So compatibility is there up to about Python 3.6. And yeah, it's really small, so it can run into 64 kilobytes of memory. Although obviously, actually doing that is really constraining, and you'd want to have 256 or more. Yeah, so the presenter here made a strong case for using MicroPython on microcontrollers. He was very involved in sensor nodes, and there's a lot you can do basically. MicroPython has a lot of its own APIs actually for dealing with hardware. So GPIO framework, for instance, and camera frameworks, and all sorts of other frameworks, including also for machine learning. So yeah, that was kind of interesting to see. I think there is a lot that can be done there, both for education, where typically things like Arduino are used. Maybe we can use MicroPython instead. It's also very useful, I think, for prototyping systems that use microcontrollers to just quickly get a few things up and running for various different use cases. So I think it's definitely worth investigating MicroPython for such use cases. Yeah, so it's also been made really convenient to actually try out. So from the looks of things, there are a tons of also IDEs that work with MicroPython, including some in the web browser. There's a package manager, so it's not pip, but I think MIP. And there is a flashing tool called MP Remote. So they try to package all of these tools as well to make it as convenient as possible to get started with MicroPython and to actually use it day to day. So yes, I think that I will actually try this because it sounds really fun. Yeah, there's a couple of caveats. So it's really best suited, I think, for microcontroller systems at the moment. You can use it on a hosted environment with your regular Linux instead of using CPython. And it is actually a lot more memory efficient if you do that. So for certain applications, it might make sense. But it lacks implementation of hardware support on hosted systems. So if you want to do the same sort of interaction with hardware that you might do on a microcontroller on an embedded platform with Linux, then you would have to write more code yourself because you can't use their nice hardware abstraction layers. So yes, also it is not very suitable for real time because it does still use garbage collection. So and especially on this sort of restricted hardware, that can mean that your entire application locks up for like 10 milliseconds. So for real-time applications, you're still better off looking elsewhere. But yeah, overall, I was quite impressed with the state of MicroPython, and I do encourage everyone to take a look at the presentation. I noticed that the recording is already online, so yeah, as well as the slides, of course. So yeah, give it a look, I'd say. Yeah, that's it for me.
Okay. Thank you very much, Frederik. Very interesting. So the next series of presentations will be those about the dev tool, the docs. I developed a special interest in documentation development when I was working on a neural simulator a long time ago. I supervised the development of the documentation of that simulator, and I came to an understanding that documentation development is actually a very complicated thing. Documentation can be out of date. Documentation can be unclear. Documentation should always talk the language of the user, not of the developer, and so on and so on. So there are many aspects to documentation development. And because of this interest, I thought to attend the dev room to the docs. I attended 5 talks of that dev room, 5, I believe, out of 8. And I must say, overall, I was a little bit disappointed by these presentations. Overall, some of them are actually interesting, that others were not very interesting. These, on the slide here, you see the 5 talks that I attended. So I'm going to go through them one by one. The first one, Org Mode, Witchcraft at Sprightly, I found that one very, say, charming, very interesting. The title doesn't fully cover what had been shown. It was more like Emacs Witchcraft at Sprightly, and it's very nice to see what is possible with such a full-featured editor. If you love that editor, if you have a religious kind of inspiration into such an editor, I'm myself an Emacs fan, so I was really charmed by that presentation. The presenter presented the entire presentation using Emacs from within Emacs, showed or used boxy diagrams and browsed those boxy diagrams during the presentation to hierarchically go through the entire presentation. I was I found it quite fascinating to see how she integrated makefiles with eLisp. Her makefile processes do a lot of stuff to publish documentation, if I understood that correctly, and she exports the org mode, which is hierarchical mode in Emacs for browsing documents, the org mode documents to some directory from eLisp, but by invoking the makefile. I found that kind of interesting. And then to conclude her presentation, she also showed Emacs-based ledger system. So a ledger and accountant system. I was actually planning to ask the question whether she could directly generate invoices from that ledger system, but I didn't get that far. But I found that a very charming and interesting, funny kind of presentation presented by someone who really loves Emacs. Just like you can love VI or Vim, it was beautiful to watch that presentation. Then the next presentation was to me personally, was a real anti-climax. The presentation, I'm not going to say too much about it, but the person presented the ls command with a few options such as -t, -s, -rt, and so on, to different sorting options for ls. Then used tree and grep and set commands, and this to process sets of markdown documents. Well, in my opinion, this presentation was really weak. I mean, most of us know all these commands, and you can easily find a few tutorials online or on the web that explains all of what was shown during that presentation. So I was really a bit disappointed by that presentation. Then the next, I still have 40 seconds. Sorry, guys. So the next presentations were a little bit high level. Patterns for maintainer and tech writer collaboration. I found it quite interesting. It was more at a philosophical level, in a sense, also at a psychological level. Was Google sponsored? Always, I find it important to mention this. Was sponsored by a big player. The core of the presentation was an attempt in finding collaboration patterns between project maintainers and technical writers. And you have to, sorry guys, you have to, how do you get these people to talk and what type of interactions are possible? The next talk was about ASCII-Doc. Was Red Hat sponsored, presented a workflow for authoring documentation, namely author, then convert, then publish, and present the talk. The talk was focused on a number of tools that support this workflow, and are focused on ASCII doc. Was interesting, but I'm a little bit concerned that it creates a structure that does not always fit well with small-scale open source software projects. And then the next talk was actually the most funny talk at all. The idea about that talk, doc straight from the code, AST power generation. So AST is abstract syntax tree. Abstract syntax tree is generated during compilation and represents all the information that is available in source code in a structured way. And so you can then convert that abstract syntax tree to JSON, and then from JSON, so JSON including the comments, documentation comments, and whatever you like. And then from that JSON generate a static website that then documents the functionality of the code that was originally used. And that's, I think, the interesting thing for me personally here was that the website was generated with Hugo. So at the end of the presentation, the guy was always saying, yeah, Hugo here and Hugo there, and Hugo this and Hugo that, which I found kind of funny. I almost felt compelled to stand up and go to the front of the room to introduce myself. Anyway, so that's it for Tool Docs, and then I believe Olivier will do the next talk.
Hello, everybody. Olivier Leroux here. I have attended several talks, probably 6 or 7, and I have here selected 2 that I found the most interesting. That's not especially the best, not especially interesting for niche, but more interesting for our business and our core activity of embedded software open source. The first was an important one. You have it on the screen here, booting blobs between Linux and U-boot. It was in the embedded room on Saturday by Marek Vazut, who is an important contributor to especially U-boot and also Linux. He works for Dengs in Germany. You have the link over there. And what does it goes about? When booting an embedded system, before, I would say 20 years ago, perhaps, it was quite simple. You just had a ROM bootloader, code written in the ROM of the SOC, that was booting an external bootloader, usually U-boot for at least ARM systems, and then booting Linux. And today it's much more complex because you have code from different vendors, different licenses, and Marek was focusing on ARM v8, but other systems like RISC-V have similar boot systems. You start from the ROM, then you boot a first bootloader that is TFA for ARM at least. Then TFA will boot at least 3 things. U-boot that will itself boot Linux, but also opt, which is a secure hypervisor, and then also a bunch of services. Actually, it stays in TFA, but it's complicated. Implements ARM standards like PSCI and SCMI. PSCI is for booting secondary cores and resetting and healthing the system. SCMI is more for frequency, power domain, etc. And what is the problem for Marek? The vendors extend the services that are running in L2, EL2. I will explain what it is. In an unsupported way. And the trouble is that the firmware is not stable anymore. We need to upgrade, especially the open source, for security reason. But if the ABI is not stable, you cannot always upgrade to newer U-boot Linux systems because the new do not respect, respect the API, but the services from the vendors do not. U-boot was meant to debug the boot system, and it has everything for that. It's a rich system. And if debugging is blocked, we have a problem. Marek's proposed solution is to reorder the bootloader stack, which means running U-boot in EL3 and thus start TFA from U-boot instead of starting U-boot from TFA. So what he wants to do is this. The ROM boots U-boot. U-boot will run a bunch of other blobs, software, Linux, TFA, Opti, and also PSCI, SMCI. And how U-boot should not depend anymore on PSCI and SMCI. And a good part is that PSCI is already implemented in U-boot, even if it's mandatory, so problem solved. Booting multiple components in a verified way, secure boot if you like, is done by fit image already. Here are the exceptions level in question. So it's for ARM specific. You have the application level virtualized OS, the hypervisor, that is the EL2, and the highest level is EL3. And it has something to do. If U-boot runs in the highest level, U-boot controls the boot. That's it for me. Frederik?
All right.
No,
Raphaël.
Is it okay for everyone if I present from here? Can everyone hear me well? Or can anyone else hear?
Yes, we can hear you well.
Okay, perfect. I think that's not the first slide, but
Yeah. I mean,
okay. So when I went to Fosdem, I could watch entirely at least 4 talks, and I had to choose one. So I chose this one specifically for the key takeaway from it, which you will learn in a few minutes. So the talk is about Wi-Fi, and it's presented by Gioacchino Mazurko. I hope I'm pronouncing the name correctly. I'm sorry if I'm not. So he first is going through the history of Wi-Fi, then formulates a problem that he noticed, and explaining candidate solutions that we've seen over the years. And then finally, he's presenting his own ideas to solve this problem. So the Wi-Fi, as we know, it started roughly around 1999 with the first Wi-Fi standards. And from the very beginning, so 2 nodes could communicate with each other, where we would typically call one the access point and the other one the station. At least in one of the modes was working like that. And from the start, direct communication between 2 access points was not possible. That's a question that Gioacchino has been asking himself many times over the years. Also, when he went to different conferences around the world, he asked people around him, why is it like that? Why can't we have access points communicating simply between them? But he never really found a satisfying answer. Basically, people were telling him that it's not possible because the standard doesn't allow it. That's not why the standard doesn't allow it. He also realized that from the very beginning, the frame format actually contains 4 MAC addresses. So we usually use 3, but there is a 4th one that's generally unused. The first 2 are the same as in Ethernet. You have source and destination, and the 3rd one can be used as the destination access points. The 4th one can be the source access points, or I'm not sure if I got the third and fourth one correctly, but the idea is that there is always a receiving access point and a sending access point, and that if you want access points to communicate between each other, you need the four of them, because you need to know who receives it, where to send it next, and where it was coming from, basically. Over the years, there has been different technologies that try to solve this problem of communicating between multiple access points. Why? Because we all know that having a single access point, for example, at home might not be enough because you want to cover more space physically. So for that, different solutions have been invented. For example, we've seen WDS, we've seen ad hoc mode, where there is not really stations and access points anymore. We've seen 802.11s, which is kind of a mesh mode also, where every node communicates with every other. We've seen Wi-Fi Direct from Google, I think. We've seen multi-AP more recently, but all of them, all of these solutions still had their own drawbacks. For example, WDS and 802.11s are not very well supported. The routing algorithm in 802.11s is bundled in the firmware, which is not ideal. So over more than 20 years of piling up Wi-Fi standards, mesh technologies have been invented, but no solution for simple AP to AP communication. So Gioacchino thought, why not try to do it actually? And his idea is quite simple. He thought, let's use beacon frames that the access points are sending to give you an ID typically every 100 milliseconds. Let's use that as if it was an association request from a station. So he actually went to look at the host APD code and studied it for many months, which is also an interesting part here. He noted that the host APD code is a bit convoluted, let's say, and that for that reason it took months to implement something that in the end is only around 100 lines in total. And he actually made it. So with around 100 lines, he now has a solution where every time an access point sends a beacon to another access point, the receiving access point is accepting it as a station and starts communicating with it. That means that if you have, for example, 5 access points, you no longer have to configure things like one station per access point that you want to communicate to. It means that all of them would communicate between each other automatically without having to support, for example, 11s or anything like that. Of course, it's still very experimental. There is no encryption support, for example. The routing protocol is also out of scope for the solutions, and the performance aspects also remain to be seen. According to Gioacchino, the performance is actually, from his early tests, the same, if not better than the other solutions. What I found particularly interesting in this talk is that some people actually still try to challenge established ideas, like, for example, that standard doesn't allow to do something specific, but why not try to do it anyway and see what happens in the end. And another aspect that I liked also, of course, is the fact that from the very beginning, he chose to make this work open source so that anyone can collaborate on it. So, for example, if you want to check it out, all the code is available on GitLab. I will very quickly go over the next 2 presentations that I prepared. I will not cover them in detail, but just to give you the key takeaway. If you need to choose a solution for upgrading embedded devices, this presentation exploring open source Turtle AD updates for embedded Linux is interesting to watch. The main, I would summarize it as good solutions already exist. Don't roll your own. But there is also no turnkey solution. So if you need management, for example, of updates, you will need to go to a third party. And also that among all those solutions, they all have their specificities. You need to choose the one that best fits your project requirements. Basically, there is not one that's better than all the others. So that's for this one. And then I also watched macros going wild with the Linux kernel. If you're interested to see how someone analyzed the entire kernel code from 2.6.14 to a more recent kernel 6. Something, it was also quite interesting to see. It took a lot of effort to do a complex analysis of how the macros are used in the kernel, what the problem with that is, and how to solve it. If you're interested, the link is on the slides.
Okay. Thank you very much, Raphaël. The next presentation is that we summarize here is about the specific applications for AI using a Ryzen chip, a Ryzen NPU. NPU is short for Neural Processing Unit. I found this a very interesting presentation. The person talking about this knew very well what he was talking about. He first introduced quickly the Ryzen AI NPUs. He discussed the structure of these NPUs, where you basically have a series of vector processors laid out in a matrix, and the challenges when programming such an NPU is the granular level of control that you want to have when compute and data movements are being programmed. And the talk, after this introduction, the talk specifically focused on reducing the bottlenecks and high performance, so the bottleneck of data movements specifically. The talk gave quite a few low-level examples of how these things were done. I added one slide, the slide with the title Adding Dimensions. So during that part of the presentation, the presenter was already deep into the matter, and he showed examples of connections between different AI tiles and how the communication between them is being set up at the lowest level. It was a very interesting talk, and I must say I'm not really sure what it has to do specifically with LLVM. It's a different, that seems something different, but nevertheless was a very interesting talk that I, by coincidence, attended. Then one other talk that I also attended was about optimizing switch statements in the GCC DevRow. The person doing the presentation had done a few optimizations for compiling switch statements. He gave quite a few examples of how switch statements are being compiled. The most popular implementation, I thought, are jump tables, but someone in the audience said that this should not be used too much because they are actually a bottleneck for performance because of the jumps. I thought that CPU branch prediction would cover this, but he said that was not the case. So I found it quite interesting. That's why I didn't add a slide to about that, but I chose a slide of the decision tree. So the presentation explains how that works. So in summary, quite simple. You have a switch statement with 8 cases from 0 to 7. Each of these cases should do something differently. How can you implement this in an efficient way? Well, you use a decision tree that scales logarithmically with the number of choices for that switch statement. Then after this type of an introduction of how these standard implementations could work, the presentation moves on with discussing a number of more optimized implementation of a switch statement. So it's important to tell here that GCC automatically detects the best implementation for the switch statement based on the case values in that switch statement. So the second slide that I have here to the right, switch lowering bit tests, it's called. It assumes that the switch cases have numbers that can correspond to a bit number in a word, and every time that you have to do something, something common, do thing A here in this slide, you set the bit in the word to 1. If you don't have to do anything, you set the bit in the word to 0. And so through bit testing, shown in the pseudocode on the right of the slide, you can quickly, or you can have a very quick implementation of this specific switch statement. The exponential transform of the switch implementation of a switch statement does something quite similarly, and that was a new addition to GCC quite recently that was implemented by the person presenting that talk.
I have a question, if I may.
Yeah, sure, go ahead.
Since you went both in the LLVM and the GC different, do you see any reason why these are separate difference?
No, I have no idea.
Hello. The next talk, which is not really a talk that I want to present, is making your product CRA compliant. It's not a talk, it is a birth of a feather presentation gathering. You may know, if you have already attended Fosdem, that the talks are interesting, but the talks you may have between the developers or with the presenters after the talk or at the booth may be as interesting as the talks themselves. And that's formalized by those birth of a feather gathering. It was led by Marta. I will not try to pronounce her family name by fear of not pronouncing it correctly. It was a full room, really full, about the CRA and compliance. CRA is Cyber Resilience Act from European Union. And it is about technical details over embedded products using open source to be compliant. And it was the purpose to chat about a number of things. There was no presentation on purpose, neither from Marta nor from somebody else. It was question and answers and an open discussions at engineering level. What I could grasp from it and trying to present it here is that the CRA might be more natural and more simple than what you could think when you hear lawyers and official presentations. You have some actors there, and they were defined. Individual contributors, like you and me. If you're just individual and contribute to open source, you have no obligation, basically. That is changed from the draft, partly in pressure from the open source world, and the European Commission has explained that to Fosdem last year and the year before. Manufacturers are manufacturers of pieces of software that could be a library. If you release a library for money, you are a manufacturer. They sell products. They do have obligations. And you have also open source stewards that are operating for profit or not, and that have some obligation, but not like the manufacturers. They need a security policy. They are obliged to report vulnerabilities, etc. The main obligation we know that already is that each product will have a support period. By default, it's 5 years, during which they need to provide security patches without delay and free of charge. Without delay is, of course, something vague that led to discussions. And especially one discussion was 5 years, but starting from which point? And it's a kind of form because it is from when it is put on the market. So suppose you have an embedded system. Suppose you produce a batch every year. During 5 years, you will have to produce to give support during 5 years after putting on the market the last batch of embedded systems. The whole will be then 10 years. What is implied by the CRA, I don't go to the details here, a risk analysis. As bombs, software bills of materials will become important, and a good idea is to document everything for possible reporting of things that are going wrong with security, especially vulnerabilities. The good message is that if we are following best practices, we are quite covered, especially because the law systems are different in the EU and in the US. In the EU, it seems essentially based on principles, and in the US on rules. In the US, you need to follow the rules, whatever, if it's meaningful or not. In the EU, you need to follow the principles, even if you are not in the details. Every product has a scope, how the product should be used. For instance, a demo board is for developers, they say, and other use are out of scope. So if you are producing a demo board and if somebody else use it in a real product, that's their problem. And the words intended and reasonable were coming several times. And by the way, about the compulsory things, you have 24 hours to report a vulnerability, but not to fix it, of course. You need to report to a national authority. And that's it for me. Arnout?
We're doing quite good on time, actually. So I have a lot of time to cover the remaining talks. So I have 4 talks selected for you. Of course, I attended a lot more. In the first talk I will discuss is one from the Lightning Dev Room. I like the Lightning Dev Room very much because it often really carries the spirit of Fosdem, in a sense, if it's people who do something in open source and are enthusiastic about it and want to show their enthusiasm to other people, and this is one example of that. Another nice thing about the Lightning Dev Room is that it's short, so if it's not so good, then it's also over very quickly. So this one, Guides for the Future, is a bunch of university students who built a guide that can be used to generate electricity. So here on the bottom, you can see the guide. So it's basically a thick slab of plastic with some propellers which are used to launch the guide, so that you don't have to launch it by hand, it can launch itself. And then a lot of control logic for steering. And then how electricity is generated is because the kite is on a wire, and then here you see how this wire is connected to the ground station, which is basically just a spool, yeah, the correct word. And then when the wind is pulling on the kite, then this will pull on the spool, and that spool is connected to a generator here, which generates electricity when it turns. So it sounds pretty simple. It's pretty cheap. So their experimental setup costs something like 3,000 euros in materials, and then also a bit of time because it's very much hobby-like, but it's fairly cheap stuff. So yeah, it's just some standard issue metal bars, and then some control logic. So it's not that bad. Way cheaper than a wind turbine, which costs millions in materials plus millions to set up. In the problem with wind turbines is you can't make them small because then they're not high above the ground and then they're not efficient. You need to be 100 meters high at least to have reliable wind. Now, the principle is fairly simple, but it's quite a challenge to make it usable because you need a lot of control. So you need a control in the generator to make sure that you don't pull on the rope when there should not be any pull. So it needs to adapt to how much pull there is. And you need a lot of control in the kite itself to make sure it makes optimal use of the wind so that it really captures the wind. It also has to move, so it has to capture the wind and then pull on the rope. But then it has to, of course, fly back to be able to, because your rope is not infinite. So it's a quite complicated thing. And so there's a lot of logic that they need to add both to the kite itself and to the generator to make this work. But it's very interesting and fun, and I think it can actually be used for something. A second talk, this was not a lightning talk, but a big one, that was mentioned already by Hugo. So it's the Software Freedom Conservancy reporting on a case they did in Germany, where an individual, Sebastian Stick, who bought this Fritzbox, he asked the producer of the Fritzbox for the source code, and he did receive something, but not enough. So he did receive the code of the components that were in there, but not the scripts used to control compilation, so he couldn't build it, and not the scripts to control installation. So even if you would have been able to build it, you wouldn't be able to install it on the Fritzbox. And so they started first discussing with AVM for a couple of years, and then in the end they went to a lawsuit. And the key takeaways about this particular lawsuit are, first of all, it's a user that started it, not an author. All previous legal enforcement actions have been by the authors. So this is really an important change. Second, it uses, so everything that was discussed here was LGPL2, not GPL3. And so the only clause in there that says anything about you have to be able to install it is this one sentence: scripts used to control compilation and installation. And so apparently that is really enough to force you to allow stuff to be installed on the box. So all these people who want to avoid GPL3 are basically wrong. That's a conclusion. And the third important bit is that it's LGPL, not GPL. So you think LGPL is lesser, so it doesn't have any teeth, but that's not true either. Now, the limitation, an important limitation is that, okay, there was a lawsuit, but the lawsuit was settled, so there's no judge that concluded this. Still, in terms of impact, it's probably the same because the reason that AVM settled, and not just settled as in gave the complete and corresponding source, but also paid back the legal fees that Sebastian had incurred. Yeah, they wouldn't do that unless they believed that this case was very strong. So basically, the case was almost up to the judge, and AVM wanted to save some money by just settling rather than going further and waiting for the results. Yeah. Now I have said all this. It's not so super interesting to look at the talk because I've said everything that there is to say about it. So it could have been a lightning talk for me. Another lightning talk is Subpatch. This I'm going to be really lightning. So it's a new project that is basically solving the problem that is already solved by Git submodules, by repo, by CAS, by the feeds of OpenWRT and many other tools. But now it tries to really solve it. You know, that's one of those things. What is it? 897, I think.
15th standard.
Yeah. So what is the problem? You have several repositories that you need to integrate, and you want to have some view of the history of all of them. So you don't want to simply copy, and you also want to have an easy time updating from this upstream that you're following. Now, the special thing about Subpatch, the Subpatch approach is it tries to find a balance between the project maintainer, that is the one that can see the complexity, so the integrator. They are the only one who have to deal with the complexity of the multiple repositories. For the user, they just do a clone of the integrating repository and they get that. So with all the others, you need to use special tools, even Git submodules. Okay, it's included in Git, but you still have to take special action in order to have something that actually works. With Subpatch, it just works for the user. Important limitation, it's very much still a proof of concept. He said, I do not take any contributions at the moment because the code is scrapped. So, but I'm planning to actually start using it. I'm not sure for what yet, but I'm planning to use it. Okay, since we're now really running out of time, I'm going to cover this in one sentence. So this this presentation, which is impossible to pronounce, is about an implementation of a Plan 9 file system over USB. So basically, the idea is it's nice when you develop an embedded system or basically a general system when you're working at a kernel level, at a fairly low level. It's very useful to have an NFS route rather than having to always write to Flash. So the context is during development when things are not fully working yet. The traditional approach with NFS is actually very painful. It's difficult to set up your laptop. It's not that easy on the device on the test either. We have experienced this in so beginning 2024. I did in mind a embedded Linux training, which was using NFS to boot, and it was for many people painful. Things like, oh yeah, the firewall actually blocks NFS. So yeah. So the idea of USB 9 PFS is to directly put the NFS between codes. It's a Plan 9 file system, not NFS, but it's conceptually the same. On the device side, put it directly on on USB. So I have a USB gadget driver that supports it, and then on the kernel side, of course, you also need a module that knows that particular protocol to talk to the device. And Plan 9 allows this because in Plan 9 there's a clear distinction between the file system itself and the transport. So it's just a USB transport instead of TCP as a transport. So yeah, conceptually simple, of course, a lot of work to implement. And that is the end of our overview of Fosdem.
Yeah, we have 5 minutes left for some
Okay.
discussion.
Yeah, thank you very much for all the presentations. Also, thank you to the audience. I would like to ask if anyone has any questions. Attila, thank you very much.
No, congrats. It was a good talk. I don't have any further questions.
Okay, so the Firefox on my laptop just crashed.
Fortunately, that's not the one that is used for presenting.
So if there are no further questions, I would like to thank the audience again for attending. I would like to thank all the presenters for presenting about relatively diverse topics, including the legal aspects. I cannot stress how important it is. And I would like to take the opportunity also to already welcome you for our next Mind Technical Talk in 2 weeks from now.
No, in 4 weeks. We decided to do it
okay.
only once per month because it was difficult to keep up the pace.
Yeah. Yeah, does anyone else have any talks that they attend that they thought are interesting? Maybe we can check them out in the meeting.
Good question.
Well, I will mention the nice Zephyr talk by Tito and Christophe. I haven't summarized it because I thought that the one I have attended were less brilliant, but possibly more useful for the audience. But the one about Zephyr and MIDI was really nice. Both from the perspective of pedagogy, it was really easy to understand, and it is really useful to show that Zephyr is indeed quite easy to use.
Yeah, indeed, it one that was a good presentation from your side. So congratulations on that. And there are also the talks I have not summarized because they were quite bad. I won't mention them. Yeah, we had to make a selection. There were more talks that we could have mentioned here. Yeah, obviously, it's a very big conference, a lot of interesting talks. There's no way to even attend them all, let alone cover them all in 1 hour.
Then there are also the many talks that I didn't attend because the room was full.
Yeah. That's an internal issue in Fosdem, yeah. All right.
Okay. Is there anything else?
No.
I think we can wrap up here.
Yeah.
Thank you all very much for attending, both attending Fosdem and attending this meeting. We hope to see you for our next Mind Tech Talk. So until then, yeah, this is Mind signing off.
Thank you very much, guys.
Bye. Bye.
Bye-bye.
Bye.
Okay.
So much more difficult to explain something when presenting compared to explaining it offline, informal discussion.
Always find the